Hello, everybody. So, my lecture for week 14, session 1, and let's continue the piping systems and pipe networks. So, in the previous lecture, we discussed the different steps to solve pipe networks. So, the first step, you need to label all pipes and junction. So, you need to write the continuity equation. You need to check it for the entire network. You need to assume flow direction for all pipes. So you need to assume actually values for some flow rates. In most cases, you need to assume 2 or 3 flow rates, and then by writing the continuity equation or mass conservation equation for uh, all junctions, you can find all other volumetric flow rates. Then you need to write the continuity equation for each junction to find the flow value and flow direction in all pipes. Then you need to identify loops and then assume actually positive direction for loop. Then you need to write the pressure drop equation for each loop, and there you will have several equations. You need to solve these equations. You need to set up a table, and then you need to just find the delta q. You need to find the q news, and uh, whenever the error is less than 2% for all pipes, you are good. Otherwise, you need to just repeat the calculations. Here you can see the flow chart to just solve the pipe network. So you need to start from assume some flow rates. Again, you need to assume 2 or 3 flow rates. In and then you can just write the continuity equation to solve to find all other flow rates. Keep in your mind that Q can be either positive or negative, depending on the flow direction in the pipe and also loop direction. If they are in the same direction, Q is positive, otherwise Q is negative. Then you can find velocities. If you remember, diameters are known in this case. So by having the volumetric flow rate, you can find the velocity. Keep in your mind that the velocities are always positive. By having the velocities, you can find the Reynolds number. You have the Reynolds number, you have the relative roughness, you can find F, friction factor, and then by having the friction factor, you can find the delta pi in each pipe. And then keeping your mind that the delta p can be either positive or negative, and then the delta pi is ci fi qi square. So you've already calculated qi, fi, and also fi. So ci is a constant. It's 8 times density times pipe length over pi squared di 5. So you can find the delta pi, and then keep in your mind that if the uh, uh, flow and loop direction, if the uh, flow direction and the loop direction are in the same direction, the delta p is c is positive, otherwise c is negative. And then you need to calculate the delta pi over qi. Keep in your mind that this term is always positive because delta p pressure drop and q, they have the same actually sign. Both of them, they are either positive or negative, both of them. So this term always positive. Then you need to calculate the delta q. The delta q is sigma delta pi over 2 sigma delta p over qi, actually negative for this value. And then you can find the second actually q, and then you need to compare to calculate the error for each pipe. If the error for all pipes is less than 2%, you are good. You need to report the q's. Otherwise, you need to repeat the process. Keep in your mind that all q's must be less than, error for all pipes must be less than 2%. For example, if there are 30 pipes and for 29 pipes this actually error is less than 2%, you need to repeat the process. You need to make sure that all q's are less than 2%. So let's solve a problem on the blackboard. I share in addition to my PowerPoint file, presentation file, I share uh, PDF file and also Excel sheet. So please open those files as well. And then for this, pipe networks, there are 7 pipes. So there is just one inlet. We have the Q in, and also we have our Q outs. And so we have the information for the pipe size and lengths for all pipes, and then all pipes are scheduled for the, you can assume that the minor losses are negligible, and then you are asked to find the volumetric flow rate for, you know, uh, all these, pipes. So in this, PDF file, I just show, the different steps to solve, this problem. So you can use this actual, file, to solve the problem. So the first step to solve this, type of problem, we need to collect some data. So what is actually those data? We need to find, the density, viscosity, and viscosity for the flow. You need to calculate the Reynolds number. So you need to have this, in actual information to calculate the Reynolds number. So the fluid is carbon tetrachloride. You need to find, density and viscosity. Also, we need to find the epsilon roughness for this pipe. All pipes are uh, commercial steel, and also we need to find the internal diameter, correct? So we need to find, this information, and then we can just those information here. So for the pipes, and then for the inside diameter. So you can pause, this video. You can spend 5 minutes and then try to find the thermophysical properties plus the inside diameter. Okay, so I use, table B1 to find the properties of carbon tetrachloride. So based on this table, you can find the density and viscosity for carbon tetrachloride. Also, we need to find, the pipe dimensions. You can use table D1, and then we have the nominal diameter, and then for a schedule for the, you can find the inside diameter based on the centimeter. You need to convert it to the meter for all pipes. And then the last one is the roughness. You can use table 3.1, and then based on this table for steel commercial one, the epsilon is actually point or equals to the 4.6 times 10 to negative 5 meter. So this is all actually information, required information, and then you can complete this table here, add all information, the inside diameter and these things here. So uh, now the first step, what is the first step, to solve this, problem? To solve, this problem, you need to label all strings and junctions. So we have actually all pipes, have been already, labeled. So we have, numbers for the pipes. So what you need to do, you need to just label the junctions. So I just use, this letters to label this junction. You can use any other numbers or letters to just label the junctions. So the next step, you need to write the overall mass balance. You need to make sure that the mass continuity equation is valid for uh, entire system. So there is one inlet, there are 4 exits, and then if you write the sigma in equals the sigma out, you will see that this equation is valid. The continuity equation is valid. This is a step 2. So for the third step, you should assume a value for Q1 and Q2. Keep in your mind that in most cases, you need to actually start with 1, with 2 or 3, actually cues to solve the problem. If you write the continuity equation for all these junctions, and then you will see that you can rewrite all, these volumetric flow rates based on two, volumetric flow rates. So let's start with the Q1 and Q2. I want to just assume a value for the Q1 and Q2. So the question is that what is the best value for Q1 and Q2? You can start with any, number, guys. But the point is that if you start with a reasonable value, then you need to spend less time to solve, the problem. So in this problem, based on you can make a decision based on the pipe diameters, based on the pipe lengths here. So the Q1 is zero point 0.4, so I assume that pipe 1 and pipe 4 have the same nominal diameter, so I assume that the 50% of the fluid goes through pipe 1, so I assume that the Q1 is 0.2. And then for pipe 2 and pipe 5, so they have actually different sizes, so you can select different values for volumetric fluid in pipe 2, pipe 5. I assume that the this is the uh, 0.2, and then I assume that the volumetric fluid in pipe 2 is 0.05 cubic meter per second. So I actually selected, the first one based on, the pipe diameters. Again, guys, you can actually assume any other, values. So I'm going to solve this, problem based on this assumption, based on these Q values, Q1 and Q2. Q1 equals to the 0.2 cubic meter per second, and Q2 equals to 0.05 cubic meter per second. So to just make sure that we get the same values, I ask you guys to start to solve this problem with different values for Q1 and Q2. For example, group 3, you can start with 0.2 and 0.1. Group 5, you can start with 0.15 and 0.05, and then eventually we see that all of us we get the same values for all Q's. So now this is the Q1 and Q2. The next step, what you need to do, you need to write the continuity equation for each junction. Correct? This is the my assumption. So both volumetric flow rate and flow direction. If you write the continuity equation for each junction, you can find both volumetric flow rate and flow direction in all pipes. For example, if you write the continuity equation for junction A, so the volumetric flow rate in pipe 4 will be 200 liter per second, and then the flow direction is downward. Correct? So for junction D, if you write the continuity equation for junction D, so this is 200, this is 100 liter per second. So the volumetric flow rate in pipe 3 will be 100 liter per second, and then from left to the side, to the right. Correct? So if you write the continuity equation for each junction, you can find both, flow direction and, flow values, I mean, in all, pipes. So please pause this video, spend 5 minutes, and then find, all volumetric flow rates and flow direction for actually based on, your initial values for Q1 and Q2. Okay, so for instance, guys, again, for this case, for pipe 5, based on, the continuity equation at junction B, the flow rate in pipe 5 is 150 liter per second, and then it's from left to the right side. So based on, this actually continuity equation at each junction, I found the flow direction and flow values in all, pipes. Now, the next step, you need to identify loops. So there are two loops, and then I assume, the actually clockwise, direction is positive for both these two loops. So the next step, you need to write the pressure drop equation for each loop. So we can write the delta PAB plus BC plus CD plus DA equals to 0. And then if you remember from the previous lecture, the delta P for each pipe equals to the CI FI QI squared. For example, for pipe 1, because the flow and the loop direction, the loop are in the same direction, so C1 is positive. For pipe 2, C is positive. For pipe 3, flow and loop are in the opposite direction. So C3 is negative, and also C4 is negative. So you can write, for both these two actually loops. Keep in your mind that the CI is a constant value, depends on density, length, and diameter. And so to find the friction factor, if the flow is laminar, you can use if equals to 64 over Reynolds number. For turbulent, you can use the Chen equation to find the friction factor. Now, so this is the summary for this part, guys. So I just assume a value for Q1, Q2. Then I found, the flow values and flow direction in all other pipes. I assume loops. And then I wrote, the pressure drop equation for all, pipes. So the next step, you need to just make the tables and then add all information to the table. So if you open the Excel sheet, file, so here you can see that I just, prepared two different loops, actually two tables for loop 1 and loop 2. So I add, the pipe numbers, the diameters. These are the inside diameters, the length, and then I calculate the C values. Keep in your mind that the C value is constant, for all calculation, because C depends on the density, length, and diameters, and all these, parameters are constant. So then you can find the relative roughness. Again, relative roughness is a constant value, because it just depends on the, epsilon and diameter is constant. So then you can just make, these two tables for loop 1 and loop 2. And then you can start with the first assumption. So for the first assumption, I assume that the, Q1 is 0.2 cubic meter per second, Q2 is 0.05 cubic meter per second, and then keep in your mind that Q3 and Q4 are negative. Why they are negative? Because they are in the opposite direction of the loop. Correct? So this is the loop direction, this is the flow direction. This is the loop direction, flow direction, this is the loop direction. So Q3 and Q4 are negative. Again, guys, keep in your mind that Q can be negative or positive values. So for the second loop, guys, keep in your mind that pipe 2 is actually common in both these two loops, loop 1 and loop 2. So it appears in both these two loops. However, in in the loop 2, pipe 2 value is negative. Why it's negative? Because in the pipe 2, the loop and flow directions are in the opposite direction. Correct? So for pipe 2 in the second loop, the Q is negative. Then you can add, the other, values for pipe 5, 6, and 7. Again, keep in your mind that for example, pipe 7, the value is negative. Why for the 7 is negative? Because the loop and flow are in the opposite direction. So this is the Q's. Then you can find the, velocity in each pipe based on, the values for the Q, and also, based on the diameter. Keep in your mind that the velocities are always positive, so you need to use the absolute value for the Q. Then you can find the Reynolds number. correct? So again, the Reynolds number would be, positive value for all pipes. So in this case, all, Reynolds number are, actually more than 2000, 200. So the flow is turbulent. So you can use the Chen equation to find the friction factor. So you can find the friction factor for all pipes. So the next step, you need to find the delta P for each pipe. Keep in your mind that the delta P can be either positive or negative. We already discussed it. So the delta P is for each pipe is Ci Fi Qi squared. So you already calculate the Ci. So you found the friction factor, and then you have the Qi squared. So it's positive if the flow and the loop are in the same direction, negative if they are in the opposite direction. So keep in your mind that the delta P and Q always have the same, signs. So here, look, the delta P for the pipe 1 is positive, Q is positive. Correct. So you can find the delta P for each pipe, and then you can calculate the sigma for the delta pi in loop 1 and sigma for delta pi in loop 2. The next step, you need to find the delta p over q, correct? So the delta p, you have the delta p, you have the q, you can calculate the delta p. Keep in your mind that this term is always positive because delta p and q have the same sign. So when you calculate the delta pi, you need to calculate the sigma delta pi over qi, and then eventually you can calculate the delta q for each loop. For each loop, delta q equals the negative sigma delta pi, this term, over 2 times sigma delta pi qi squared. Correct? Yes. Now, you actually finish the first, iterations. So you calculate the delta P, you calculate the delta Q, and now you can calculate the new Q, the second Q, correct? So here, let's go scroll up. Yeah. Look, guys, this is the first assumption, and then now you found the delta Q. So by having the delta Q, you can set the second, iteration. How? For the second iteration, Q new equals to the Q old plus delta Q. So this is, the new value for Q1. So for Q1, so the Q new equals the Q old plus delta Q. So keep in your mind that because the Q2 is in both, loop 1 and loop 2, you need to apply the delta Q for both these two loops to calculate the Q2 new. So you need to actually add the delta Q for the first, loop, and then negative delta Q for the second loop. So yeah, by using this method, you can find all Q news. Now you need to check. Keep in your mind that the value for the Q is in actually in the opposite sign of Q in the first loop, in the second loop. Now you have the Q new. What you need to do, you need to actually calculate the error, between the Q new and Q actually, old, to see if the difference is less than 2%. So this is the first value, this is the second value. I calculate, the percentage error. So I use the absolute value and then Q new minus Q old over Q old, and then multiply 100 to calculate, the percentage error. As you can see, all actually errors are more than 2%. So what we need to do, we need to repeat calculation. So and then you need to just continue to the third loop. So here is the second loop. So what you need to do, again, you need to calculate the velocities, Reynolds number, friction factor, delta P, and then delta P over Q, and then Q new, and then by just using, this delta Q for loop 1 and loop 2, you can calculate the Q new for the third iteration. So this is the Q new, for example, for pipe 1. For pipe 2, you need to apply for both delta Q in loop 1 and loop 2. And then for example, pipe 6, you just need to apply the delta Q in the second loop. So what you need to do, you need to actually calculate error, for the third, for the Q3. So if you calculate Q, you will see that the error for the third one is more than 2%. Only we have, error less than 2% in pipe 1. Sorry, pipe 5, but this is not acceptable. You need to have, error less than 2% in all, you know, um, actually pipes. So what you need to do, you need to repeat this process, and then just you can stop when all errors are less than 2%. So I just continue, this calculation. Then the only thing is that, guys, you need to just check, the sign for the Q, correct? So the sign for the Q, sometimes, you start, for example, with the positive value, and then based on the calculation, this value, convert to the negative value. So you need to just make sure that, always delta P and Q have the same, sign. You just need to take care of, this, point. Otherwise, everything is, straightforward. So again, just make sure that, Q and delta P have the same, sign. Sometimes, based on the calculation, the sign of this Q, changes in the new values, and then the delta P will have, the opposite direction, and then everything, will be actually right. So just make sure that these two columns have the same, sign. So I just repeat this process, and then here you can see, the values for, error, and then eventually at the ninth, iteration, all, errors are less than, 2%. So, yeah, here you can see this is the first, iteration, and then the second one, and then here you can see, the results. So for the second, iteration, all, errors are more than 2%. I continue for the third one. There is just one, pipe with the error less than 2%. For the fourth one, we have two pipes with the error less than 2%. So we need to repeat it. For the fifth one, again, we have two pipes with the error less than 2%. So we need to continue. For the sixth one, we have three pipes. Again, we need to continue. Seven, we have, more pipes with error less than 2%. And then at eight, iteration, there is only one pipe with the, error more than 2%. And if we just continue to the ninth one, all, errors will be less than 2%. And now what you can do, you can just report, these, values, correct? So I just report all, values here. So yeah, keeping in mind that, guys, let's go back here. For example, look, the first, part. So the Q is 0.1689 cubic meter per, second. So this is a positive value. This is positive value, meaning that, the flow direction and, loop direction are, actually the same. So so the flow in the first actually pipe is from the left to the side, and the value is 168.9 liter per second. However, for example, for the, let's say, pipe 7, so the flow value is negative, meaning that, it's in the opposite direction of the loops, actually, uh, direction. So the loop direction is from the, right to the left. So the flow value in the flow direction in the pipe 7 is from the left to the right, and the value is 86.6. Please pause this video and then spend, 20 minutes. Try to find, the values for all pipes of both values and direction for the flows in all pipes based on your initial value of Q1 and Q2. Okay, so to compare the results with my result, I just repeat this actually process with different initial values of Q1 and Q2. So again, I started with I label all streams and junctions. I just wrote the overall mass balance, and then for the Q1 and Q2, I started with 100 liter per second and 50 liter per second. These are, my initial values for Q1 and Q2. Let's solve the problem based on this, Q1 and Q2, and then we just compare the results, for both these two cases. So the next step, what you need to do, you need to write the continuity equation for each junction, and then you can find both flow value and flow direction in all other pipes. So for example, based on this assumption, Q4 will be 300 liter second per second and downward. So then Q3 will be 200 liter per second and from the left to the right side. So Q5 will be 50 liter per second, and then you can just find all other Qs. So what is the difference between this case and the previous one? If you compare this case with the previous one, some actually volumetric flow rates has been changed, based on this initial assumption. The other thing is that the flow direction in pipe 6 now is, in the opposite direction. In the actually previous, assumption, when I use, the 200 liter per second, the flow direction was from, in the opposite direction of this direction, actually from the, let's say, right to the left. Now it's from the left to the right side. So now the next step, what you need to do, you need to identify the loops. There are two loops, and again I use the clockwise as the positive direction, and so you just need to write the uh, pressure drop equation for each loop. So the difference here is that this flow direction in the pipe 6 now is in the opposite direction of the loop direction. So C6 will be negative. So this is actually different from the first solution. Now the next step, you need to just set the tables. So I have the tables here. Let's scroll down. Yeah, here you can see the results for Q1 and Q2 equals to 100 liter per second and 50 liter per second. So again, I just calculate the velocities, Reynolds number, friction factor, delta P, and then I calculate the sigma delta pi, sigma delta pi over qi, and then I calculate the uh, delta Q for each loop. And then based on these values, I calculated the new actually values for Q's. So now let's calculate the error percentage, for the actually uh, second, iteration. So here you can see the error percentage. As you can see, for the second iteration, all, error percentages are more than 2%. So what we need to do, we need to repeat the process. So I just repeated, for several, iterations. So as you can see, everything is the same. The only thing is that for when you start the fourth iteration, if you look at the table, guys, look what happened. So Q6 was negative in the third iteration. However, in the fourth iteration, it just converted to the positive value. based on the value that we use for the for the Q new, which is the Q old plus the delta Q. Correct. So now this is the positive. What you need to do, you need to take care of this delta P. Keep in your mind that delta P and Q have always the same sign. So now this is the positive value. The delta P must be positive. If you look at in the third iteration, delta P for the pipe 6 is negative. However, in the fourth iteration, the delta P now is positive. Just again, make sure that the Q and delta P have the same sign. And then keep in your mind that the delta P over Q is always positive. So I just repeat this process for several iteration, and then I calculate the uh, Q, the error percentage, and you can see here the results. So yeah, here is the results for the Q1 equals the 100 liter per second, and Q2 equals the 50 liter per second. As you can see, for the third iteration, all percentage errors are more than 2%. So I continue for the fifth one. Also, all errors are more than 2%. And then what happened for the sixth iteration? There are four pipes with the percentage errors less than 2%. So what we need to do, we need to actually continue the iteration method to make sure that all these errors are less than 2%. So for the seventh one, there is just one pipe number 6 with 40 actually 0.8% error. So we need to repeat it. So for the eighth one, guys, if you look at the percentages error, the percentage errors decreases for all pipes. So for the pipe 6, it decreases from 40% to 10%. Again, it's still less than more than 2%. You need to repeat it. So for the 9 one, it decreases from 10% to 3.9%, and still we need to continue it, and then eventually, and the elements, iteration, all error percentages are less than 2%, and this is acceptable. This is good. Now you can report, this volumetric flow rates as the volumetric flow rates of this, problem. So, yeah, what is the difference between actually this method and the previous one? In the previous, assumption when you use, the 200 liter for, pipe 1, we just reached to the answer. We got the answer after, ninth, iteration. Here we have two more actually steps to find, the values. So here you can see that if you start with a, reasonable loss, you can get, results. Actually, you need to spend less time, to get the results. Okay, so here is a comparison between, these actually the results for two different initial values. Correct. So if you compare the values, guys, you can see that they are pretty close. For example, for pipe 1, when you start with 0.2 cubic meter per second, the Q1 is 168.9 liter per second. And for the second actual scenario, the Q1 is 168.2 liter per second. That's really good, correct? For example, for pipe 7, the volumetric flow is 86.6 for this first scenario, and for the second one is 87.4. Keep in your mind that, guys, if you continue iteration, if you actually spend more time, if you decrease, the error percentage, for example, if you set error percentage less than 0.5%, then you will get more accurate results. But I think 2% is good, and then you can just report the results. So please solve this, a problem based on, your initial values, and then actually I will post, the individual project too, which is pretty close to this, problem. Thank you so much and have a great day.